So now we will discuss about the difference between mechanism and machine. So mechanism, which means it is a collection of links that works together to perform a job, right? Number of links are joined together to perform a job, which is called as a mechanism. Whereas machine, it is assemblage of mechanisms which are used to transmit motion and force or to perform the useful work, right? So let us see example for mechanism. Mechanism, it is a scissor. Scissor comes under a mechanism because number of pairs, number of links that works together to perform a job. Whereas for lathe machine, so it's assemblage of mechanisms. See here, quick return mechanism is there. With the help of this mechanism, we can give input and we can get output, right? So this is the difference between machine and mechanism, right? Then we will discuss about the structure or locked chain. The structure is nothing but it is an assemblage of resistant bodies without any relative motion between the links, right? There is no relative motion between the links, or the links are connected in such a way that there is no relative motion between the member, or between there is no relative motion between the links, right? So here degree of freedom, which is equal to 0 for structure. That we will discuss later what is meant by degree of freedom, right? Now so many practical examples of structure. For example, roof trusses, then bridges, buildings, machine frames, all are comes under structure. Okay. Then now let us discuss the difference between the structure and machine. Structure and machine. So for structure, no relative motion exists between the member, whereas for machine, the relative motion exists between the parts. Alright, and moreover, the structure, it transmit only forces, whereas machine, it transmit forces and even motion also, right? And the links are meant, the members are meant for carrying forces, right? Whereas here the transmit motion and force. Then so many practical examples are there. For example, here I have mentioned roof trusses as an example for structure, whereas for machine, washing machine, cars, toys, lathe, here I have mentioned screw jack. Okay, that we will discuss in our next video. Okay, thank you. Yes, welcome to my YouTube channel. We are mechanical engineers. So now we will discuss about the types of motion based on the nature of constraints. So this is majorly divided into three categories. One is completely constrained motion, and incompletely constrained motion or unconstrained motion. The third one is successfully constrained motion, right? So completely constrained motion, incompletely constrained or unconstrained motion, successfully constrained motion or partially constrained motion, right? So let us discuss one by one. First we will discuss completely constrained motion, right? When the relative motion between the two links is limited to definite direction, then the motion is said to be a completely constrained motion. See in this picture, you have to consider this is 1 and this is 2. Two links are there, link 1 and link 2. So link 1 is a fixed block having a rectangular hole, and link 2 is sliding a rectangular bar. So here only one option is there. This link 2 we can slide in the horizontal direction, right? So this is the only one possibility. So degree of freedom for this, which is equal to 1. So we can move the link 2 in only one direction, right? Whereas the second one, it's incompletely constrained or unconstrained motion. So degree of freedom, which is equal to more than 1, right? That we will discuss. See here, when the relative motion between the two links, here two links are there, this is link 1 and this is link 2. The relative motion between these two links can take place in more than one direction, then the motion is called incompletely constrained or unconstrained motion. See, you have to consider this is the fixed hollow block and link to which is the shaft. So here the two possibilities are there. We can rotate the shaft, that is one possibility. The another possibility, we can reciprocate or we can slide this link to in the horizontal direction. This is the second possibility. So two different type of motions are there. So the degree of freedom which is equal to 2 for incompletely, I mean more than 1 for incompletely constrained or unconstrained motion. The last one is successfully constrained motion. See here, the unconstrained pair converted into constrained pair by some means or called as successfully constrained motion, right? See, when the relative motion between the links is not completely by itself but it is achieved by some other means, then this type of motion is said to be successfully or partially constrained motions. See, best example for this successfully constrained motion is a footstep bearing, right? Thank you.